Problem 3, Exercise 3, once again gives the authors an opportunity to try to impress you with how bloody cosmopolitan they are. They're talking about Mittelline of Köln, Germany. Köln is Cologne. So, same city, 31,000 tons of bombs dropped on it by the RAF during World War II. It's that city, Cologne. They would like to reduce the amount of time between when a customer places an order and when the order is shipped. This is something that you will be dealing with. Throughput time, production time, how long between when a customer says, I need, until your team says, here it is. You're going to have to be able to work on that. That's a common problem. The data for the first quarter gave us the following information. The inspection time, 3 days. Inspection time is not value-added time. Inspection time is somebody standing there with their hand behind their backs going, yep, you did it. Wait time. From the time you receive the order until you get off your dead butt and start doing something, that's wait time. That's not value-added time either. Process time. The time it takes to actually do something, to produce something. Yes, that is value-added time. That is value-added time. That is valuable process time. Move time. That's the time it takes to move something from one machine to another machine so that machine can start its work on the process. Move time is also not value-added time. It just sort of stands there. And the last one is definitely not value-added time. It's queue time. It's how long that machine stands in line at the new machine before work begins on it. So of all of those, the only time that is really value added is process time. Now, ideally, you would get your processing down to the point where your process time would be all the time you would spend, but that's really kind of unrealistic. It would mean that an order would fly through the window, fall on somebody's workbench, and they'd immediately start working on it. That's not likely to happen, but you want to minimize everything but process time. That increases your general efficiency. So the first thing they ask us to do is compute the throughput time. So that's process time plus inspection time plus move time plus queue time. Okay? That's the total throughput time. So we add together our throughput time. So we add together 2.7 days. That's our process time, plus our inspection time of, what was that, 0.3 days? 0.3 days. I don't know how you spend a third of a day inspecting something, but I guess you can. And then you have 1 day of move time. Must be a pretty big factory. You got to take the whole day to move from one end to the other. And then you have 5 days in queue time. 5 days waiting at that last machine, or that next machine, or those next machines, because this could be cumulative. Could be 5 moves and 5 wait times, all added together. So when you add that together, you get 2.7 plus 3.3 is 3, 4 plus 5 is 9. So our throughput time is 9. Okay, so we want to see our efficiency. We want to look at the value added time divided by throughput time. So our value added time is 2.7 days, just that. Our throughput time, the time start to finish, is 9 days. Gives us 0.3. So, if our manufacturing cycle efficiency time is 0.3, okay, that means basically 30% of our time is useful. That 30% was spent in value-added times. But the important thing, if 30% was spent value-added, 70% was non-value-added time. That's an important consideration. So we computed that, we computed the delivery cycle time. Now it says, if by using lean production, all queue time, all that time waiting in line at the end was eliminated, what would be the new manufacturing cycle efficiency? I just happen to have that handy. Well, if we can do that, we can look at, and we can take our value added time. Oh, by the way, the delivery cycle time was the wait time plus the throughput time. I kind of skipped over that. That was this one here, the delivery cycle time. That's the wait time, 14, plus the throughput time, the 9 that we computed. So the delivery cycle time, the total time from when we get an order till we ship it out the door, is 23 days. That could be pretty terrible, or it could be pretty good, or it could be phenomenal, or it could be horrible. If it's a pizza joint, I'm guessing 23 days is a bit long. But if it's a car dealer, and you're making a car in 23 days, it's probably pretty good. So you have to look at the other entrants in the industry. So you can't just take one single number and go, aha, this is good, or aha, this is bad. But you have to know what it is. Now the last step, it says, if by using lean production, all queue time is waiting time. If all queue time is eliminated. So we just have our value added time of 2.7. Okay. So we have our value added time of 2.7. We did this piece right. That was the 14 plus 9. I'm sorry. So if all queue time can be eliminated, our value added time becomes the 2.7, the 0.310, 3/10 for inspection, and 1 day for move. So we've gotten rid of all wait time. So when we move the machine, when we make a product, we inspect it, we move it to the next station, they start work right away. There's no wait time. If we can do that, we've reduced that to 4. So if we can do that, get rid of all the wait time, our value added time is 2.7, our throughput time is 4, because we got rid of all the wait time. Our manufacturing cycle efficiency goes to 67.5%, which means we're running pretty lean, we're running pretty efficient, and that we're only wasting or not adding value. What's the difference here? 33% of the time, 32.5% of the time? That's pretty good. So just by getting rid of the wait time, we can increase our efficiency significantly. And you have to be able to do this. You have to spend the time to look at all the processes. Just because you've always done something one way doesn't mean you always should do it that way.